All right, guys, today we are going to talk about how to graph quadratics in Vertex form. So if we want to add to our table of contents here, we're going to put graphing in Vertex form. So just like we have with a line, a quadratic has three different forms of the equation. We got vertex form, standard form, and factored or intercept form. So we're going to spend some time talking about how to graph each one and kind of talk how they're related to each other and how they're different from each other. So there we go. Now, I know this may be a little confusing because I don't have this in a notebook, but on the left-hand side or on page 29, you're going to have a little half sheet of graph paper. And then on the right-hand side, we'll have this little note card here and that there. I'm probably actually going to write some stuff underneath this note card. Okay, so starting up here, this is what our vertex form of a quadratic looks like, the equation of it. And so it should look very familiar to you because so far this year we have talked about A, H, and K a whole ton. Okay, so identifying your A, H, and K values are going to be super duper important here. Whatever your A value is going to be sort of your slope-ish. So when we talked about our parabola, the shape of our graph, we noticed that the slope was not constant. It's changing, like it's either slowing down or speeding up. And so we don't have true slope here. However, we can use A as the slope one time. So slope-ish, use once. And the other thing that's kind of strange about it, so you can only use it once, and we have to do like use it as rise over 1. So you always have to, whatever that A value is, you always have to do that number over 1. So like that's fine and everything. If your A value is 2, you're going to go up 2 over 1. It's just weird when it's a fraction. So if my A value was half, I would have to go up half over 1. So that's kind of when it gets a little strange. But it's still kind of helpful because it gets you a good idea of what your graph is doing. If it's positive, we can make this little note. If it's positive, we have a pointing up parabola with a minimum. If it's negative, we have a pointing down parabola with a maximum. So that's also helpful to figure out the shape of my graph. The other thing that you want to identify are your H and K values, keeping in mind that H is always opposite because of that negative in front of it in the equation itself. Just like it has been in the past, whenever I take it out of the absolute value symbols, whenever I take it out of parentheses, I always have to change the sign. And so your H comma K will be the vertex, and you're really going to want to plot that first. Now, the other super nice thing about your vertex is a lot of key things happen there. So at the vertex, that's where like the change in direction of your graph is happening, so that you can do your slope from the vertex. The other nice thing that happens is at the vertex, you get your axis of symmetry that goes straight through it. That will be at x equals h because it's going through there. So that's kind of nice. So underneath this, you guys should have in your notebook like some paper right here. We're going to write our steps for graphing success. So steps for graphing success. Step number 1, you want to plot your vertex at h comma k. I mean, kind of in addition to this, draw your line of symmetry, or draw your AOS through x equals h. So those kind of happen at the same time because it's in the same spot. The second thing that you want to do, once you have your vertex, that's where all the good stuff is happening. That's where parabola is going to be changing direction. Second thing we can do is use A as slope once. Again, you can only use it once. It's so important. And we always have to do it as rise over 1. Now at this point, you'll have a pretty good idea of what your graph looks like because you'll have the vertex. You'll be able to do your slope on either side because of your line of symmetry. However, we can get one more pretty easy point. Another easy point that's quick to find is the Y-intercept. So we can find the Y-intercept by putting 0 in 4x. And also, like once you have that, you'll be able to get another point because of your line of symmetry. So that's super nice. There are steps for graphing success. And now we're just going to practice a whole ton. So in our little magic book here, we have our axis of symmetry. So we have our equation again in vertex form. Our axis of symmetry is always going to be at that x equals h. The vertex is at h comma k. And your y-intercept will always be at 0 comma some number that I find by plugging that in. So like what you're going to end up with is a parentheses 0 minus h squared plus k. And like you're going to want to follow order of operations to get that number. Okay. So try a couple where we have the equation and we want to graph. So for example here, I can see my a value, and sometimes I just go right in order of the numbers. So my a value here is -2. So my slope to one point is -2 over 1. My vertex are going to be these two numbers, keeping in mind that the number I take out of parentheses has to change. So -2, comma 3. Now because I know my vertex is at -2, comma 3, I also know my axis of symmetry is at -2. I can tell that this graph is going to open down because a is negative. And then we'll find our y-intercept in a minute. I actually wish I would have kind of graphed as I went there because I think we would have thought through it. I'm going to do it on the other one. So I will first, like I said, plot my vertex at -2, comma 3 and draw my line of symmetry through it. I can then, second, use my a value as slope once. So from here, I can go down 2 over 1. And because I have this line of symmetry, I can flip it over and put it on the other side. And so now I can really see that my parabola is pointing down. Now we want to keep in mind that a parabola is U-shaped, not V-shaped. So like when I connect my dots, I don't want to make straight lines. I want to make curvy lines. And then the last thing that we can do here is find the y-intercept by putting 0 in place of x. And so 0 plus 2 will be 2 squared is 4. And so we have -2 times 4 plus 3, which is -8 plus 3, which is -5. So I can go on my y-axis to -5. And then I can get another point because we can reflect it over our line of symmetry. And then look how nice that parabola looks. So cute. Pointing down. If we think about domain and range, oh. So the domain, this graph is pointing left and right. So all real numbers. The range, however, this graph is pointing down and down. And so the range is going to be y is less than or equal to however high it got, which it got as high as 3. Cute. Okay, let's try another. So looking at my equation right here, I notice that my slope is at half and my vertex is at 4 comma -3. So I'm going to kind of start graphing right now. Usually that's all I need to feel pretty good about going to a graph. So I'm going to plot my vertex at 4, -3 and draw my line of symmetry. Which reminds me, my line of symmetry is at x = 4. Then I can do my slope. So my slope to one point is 1/2 over 1. This is kind of the weirdness. So we start from our vertex and we're going to go up only 1/2 and then over 1. And the thing is, because my line of symmetry, I can flip it over and put it on the other side. The other point that I can find, now I can already see my parabola is pointing up, which makes sense because we're positive. I can get another point by finding the y-intercept, so we'll do 1/2 parenthesis 0 minus 4 squared minus 3, which 0 minus 4 squared is 16, and then 1/2 of that is 8, minus 3 is 5. And so we'll plot my y-intercept at 5. And I can flip this over and put it on the other side. Now really how I'm doing that specifically is I'm like counting the squares to my line of symmetry and then counting the same amount of squares on the other side. Look at that cute parabola, curvy lines, not straight lines. Now this one is interesting. Domain, it's going left, it's going right, so still all. In fact, all parabolas will always have all real numbers as their domain. Range, this time, we're up and up. And so that means the y values are getting bigger than or equal to some smallest amount. And the smallest or minimum is -3. Cute. Okay, so we want to be able to go both ways. So if they already give me a picture of a graph, I want to be able to write the equation of it. And so I want to write my equation in vertex form, mainly because that's the only one we know so far. But also, like, they are showing me the vertex right here, and I can tell because it's like the lowest point on the graph. And so I can just put those in for h and k. So that's kind of the first thing I do. I put x minus -4, so +4, minus 2. Then the thing is, the reason they're showing me this other point is so I can compare these two and figure out what is the slope from one point to the next, because these are 1 away, and we went from -2 to -1.75, so I feel like we changed by 1/4. So I think that means my slope is 1/4 because of the difference there. And there you go. That's kind of it. You just look at it and count. So looking at my other one, we're also going to write this guy in vertex form because they are showing me the vertex. And so I can first do x minus 2 squared plus 6. And then I want to count out my slope from one point to the next. And this is 1 away because we're 2 to 3. Looks like it's went down 3. 1, 2, 3, yeah. So -3 is my slope. Boop. Boop. And then the last thing that we can try is taking our vertex form of a line, or of a parabola, geez, and change it to standard form, which is our ax squared plus bx plus c. And that's sometimes important to do for reasons that we'll talk about later. And so the way we do that is we really just need to follow good order of operations. So this one says that I should square x plus 1, which means to multiply it by itself. So hopefully remember, if we are multiplying two numbers by two numbers, we should do something like FOIL, distribute twice, do the box, something like that. I'm going to just distribute twice. So I'm going to take the x and multiply it to each of these. So x times x is x squared, x times 1 is 1x. Then I'm going to take the 1 and multiply it to each of those as well. So 1 times x is 1x, 1 times 1 is 1. Now I haven't done anything with the 2 yet because that's also being multiplied, and I can really only multiply two numbers at a time. So I'll bring the 2 down, and now I think in my parentheses I'm going to combine some like terms. So I'll have 2x plus 1, and now I'll distribute the 2. So 2x squared plus 4x plus 2 is in standard form. Okay, so same idea here. We have a negative x minus 3 squared, so I'm going to want to do x minus 3 times x minus 3, and then I'll worry about the negative, and then I'll worry about the 4. So again, I sort of have 3 numbers being multiplied here, the negative 1 and the x minus 3, so I can only do 2 at a time. I just always like to take care of the parenthesis ones first. So we'll distribute twice again. So x times x is x squared, negative 3x, negative 3x, positive 9. And then all that has the negative, and then we have a plus 4 at the end. I'm going to combine those like terms again, so negative 6x plus 9. Distribute the negative. Now it ends here, and then I have a plus 4, and so now I have a couple more like terms that I can combine. So we'll have negative x squared plus 6x minus 5. Okay, just because I don't want to make this video too long, I am going to do a second shorter video where I do a couple more examples of graphing, but I'm going to do that separately. So I'll see you in the next one.